So what we're talking about today is going to be audits of chatbots and how they might work differently with different types of prompt inputs. So first off, lots of us have probably been forced to interact with chatbots in, for example, the Amazon use case, something called Rufus, where you might have to ask a question about something you're shopping for, and you get some personalized response. Now, this isn't specific to Amazon, and we have plenty of work already telling us that these chatbots often don't work, right? In government examples, in education examples, in tax examples, these are fundamentally kind of flawed technologies. And in a separate line of work, less focused on chatbots, but more about LLMs, we also have seen a lot of work showing that if you write your prompts differently, if you're using different types of written dialects, for example, you're going to end up with very different types of responses. And so I know Dan is in the room here, so this is a shout out to his paper, thinking about the different ways that linguistic biases can manifest in GPT responses. And so in particular, we're going to focus on dialect biases here, where we're thinking about dialect normally as kind of a speech-based mechanism, right? So you have the things you say being in a different order or using different words, so grammar or lexicon, but also maybe speaking in a different way, acoustically, so phonology differences depending on dialect. But in fact, a lot of this previous work on LLMs and also what we're doing with chatbots is thinking about dialects in writing. So when you're actually physically writing something, how might LLMs manifest differently in response? And so we might see dialect biases when, for example, someone says, "I am so happy," which would be in quote-unquote standard American English, as opposed to "I be so happy," which is an example of habitual be, a grammatical formulation often used in, for example, African American English or in Singaporean English. And in this particular example from Hoffman et al., you might see that someone who speaks in standard American English in writing would be considered brilliant and intelligent, but someone who uses the habitual be formulation grammatically will end up being categorized as lazy and stupid, right? So this is all prior work that has been done more broadly speaking on LLMs. And what we do differently is we're focusing instead on chatbots. And so the first main piece that we cover in our paper that we don't have time to get into today is thinking about, in particular, the reasons that existing work can't directly plug and play into the chatbot context. So a lot of the work that historically has been done on audits are based on kind of pre-existing corpora that don't quite work in the chatbot context. If you think about the types of speech that you're using much shorter phrases, you're thinking about conversational turns, and that just doesn't quite work well with a lot of other existing corpora that people tend to use to audit longer form text. So see the paper for more details on that bit. And what we're going to be focusing on in this presentation is our broader framework that we propose for auditing chatbots for dialect bias, and in particular, measuring the extent to which they produce quality of service harms, i.e. harms where different people might be affected differently. And in particular, we're going to talk you through our case study of Amazon Rufus and find that it, in fact, produces lower quality responses for different types of English dialects. Okay, so this is the full framework, but we are going to talk through it bit by bit. There are kind of 5 key points that we're going to hit. So the very first one that we're going to talk about is target identification. So we want to first identify an actual chatbot and then work with it in order to conduct this audit. So again, like I mentioned, we're working with Amazon Rufus. And in particular, you need to query the chatbot through some environment. So in our case, the main results that we're going to present are from literally using this particular chatbot, but a lot of what we go into the paper involves how to make a copy of the chatbot. So if, for example, you know what prompt instructions are being used from GPT, for example, you can automate this process as long as you do an additional auditing step to make sure your copy of the chatbot is consistent with the actual chatbot responses. So this version, more manual, you can do a more kind of work-intensive but much faster and scalable copy version of a chatbot. Next point is on prompt collection. So how do you actually collect reasonable and realistic user prompts? Conveniently, Amazon actually has nice blog posts with some examples, right? And so we can use these to come up with what people tend to ask. Next, we do some prompt perturbation. So ideally, you want to specify which dialects you actually care to audit. and then transform user prompts across dialects. So one perhaps most valid, ecologically valid way to do this would be to actually have speakers of different dialects to perform these sorts of translations themselves. But if we don't do that, we can use tools like multi-value by Zeems et al. Out of D.E. Yang's lab to programmatically transform different texts into different grammatical formulations based on a series of rules. I'll add in a caveat here, which is you might be tempted to say, like, what if we just use an LLM to do these transformations? See Emma's previous work that shows that actually this works quite poorly. Like, every time you ask it to translate some standard American English phrase into African American English, it will preface something with yo, which is not what we want. So be careful in choosing how you actually perturb your prompts. And so in particular, what we're going to focus on in this particular case study is we have our set of base prompts from Amazon. We have some not transformed, quote unquote, standard American English prompts. And then we use the tool multi-value to do a few transformations into 6 different dialects or varieties of English. In addition to looking at different dialects and varieties of English, we also do a few additional perturbations that make our prompts a bit more realistic to how the average person probably types. So in addition to looking at everything that looks like formally written, we also try lowercasing everything. We also try removing punctuation from everything. And then we also try perturbing things with typos. So also see Emma's GitHub for code on basically perturbing things with adjacent letter typos. OK, so what we then do is, of course, collecting responses. So first of all, repeatedly querying the chatbot with these different versions of each of these prompts. But also what we need to do is define a metric, right? So what do we actually care about for measuring response quality? Here's an example of one of the main metrics we talk about in the paper, which is just baseline incorrectness. So a binary value for whether or not this makes sense. In particular, for this example, we are asking about OLED TVs, but inserting a typo that flips the E and the D in OLED, which gives us old TVs written in medieval English. And of course, Rufus then produces factually inaccurate responses, like about vintage aesthetics. So this is an example of an incorrect response. We also look at other metrics. So basically, the number of times that Rufus might ask, what exactly did you mean, or how else can I help you? So these sorts of kind of uncertainty metrics are also something that you could consider. And so finally, what we do is we evaluate the differences in response quality, right? And so at a very high level, what we see here is that responses are significantly more inaccurate for especially African American English, Indian English, and Singaporean English relative to quote unquote standard American English. And this is especially compounded when typos are introduced in your search queries. And as one example of this, you might have, for example, the raw question, is this jacket machine washable, which gives you the correct or a reasonable answer in Rufus. But if you use, for example, a zero copula grammatical formulation, so removing the is, and instead saying this jacket machine washable or this here jacket machine washable, you end up with a totally inaccurate response. And in particular, this sort of grammatical formulation with zero copula, we see quite frequently results in inaccuracies, which is kind of, I mean, obviously it's not nice, but this sort of finding does indicate that actually there is potentially a solution to this, which is training with more grammatically variable inputs in the training data, which could potentially ameliorate these sorts of harms. Okay, so thank you for your time, and please direct all questions to Emma.